Hey there, welcome back to the Compiler Show. I thought that today I would take a crack at an early return if error feature, almost exactly like Rust's question mark, that's based on a built-in type class or ability or interface, if you will. So let's get started. I haven't really started. So I have an unwrap ability, which I use for something kind of similar. This is, what you can think of as like your canonical optional. An optional container, you can ask it if it has a value, and then you can get the inner value. This would crash if it doesn't have a value. This is a base interface you can use and then implement on your type so that you can use certain features in the language that understand optionals. Mainly the question mark operator at this point in time. But that's not what we're doing. We're doing early return. So I don't know what to name this because I kind of want our main result bifunctor. So, like Rust's result type, lots of languages have something like this. It's a bifunctor because it's like you can map over it two ways. It's, it contains two values. But basically you have, either it contains a T or an E, and then we assign an actual meaning to those with OK and error. You might see it in a more pure form, literally with just like, left and right, where you're not claiming or ascribing any particular meaning to left and right. You're just saying this thing might contain a T or an E, and you contain a tag saying which type it's going to be. But in practice, really what you want is usually what we call a biased result, where if I map over it, I'm mapping over the OK, I assume it's OK, and then I would have like map error to talk about the other side. Usually you have like a main channel and then like a failure channel. But sometimes you have like equally valued sides, and in that case you wouldn't use result. Of course, you'd use maybe something like either, or you would just name the tags. But I digress. So here's our result type. And we'll implement, of course, our thing for this type, but the point is that you can do it for any type. There's nothing special about this. And we have our resulty. I don't really have a way to make an one ability sort of, I can't compose abilities at this point in time. So let's just make it from scratch. Let's not worry about results. So we're going to have is success, which will also give us is error. But let's not put that in here right now because we don't have default implementations anyway. What you'd want to do is have is error and actually provide a default that's just, the negation of is success, and then no one has to implement it. They get it for free. We say, hey, just implement one of these, right? But I don't have default impls. So we're not going to do that. We'll just do the one side. We'll do get error, and I guess we'll do get success. So what is E and what is T? So we need this ability to know about some types. So if I implement resulty for a type, I think I only want to be able to, it's determined by the type what the success and error types are. It's not determined by the caller. So when we do type classes, we have to think about this. So an example of determined by the type would be iterator. If I iterate over something, the type of each element is determined by the thing, not by the caller. When would it ever be determined by the caller? Well, what if I call into in Rust, right? I want to turn this thing into that type. Well, it'd be like, which type do you want to turn it into? The caller says, in that case, the caller is providing that type parameter. And I've codified the difference. Rust codifies the difference between these two types of type parameters using what it calls, to make sure my audio is not clipping. All right, I think it's like close, but. So Rust codifies this by talking about the actual type parameters and then the associated types that you put down in the body. So I've done it a bit differently by declaring them as like impl, because really the ones that are provided by the implementation are exactly that. They're provided by the implementation. They're not provided by the caller. So unwrap has one implementation parameter because a type can only implement unwrap once. And the implementation says which type is inside. So for resulty, we'll do the same. We'll have two implementation parameters. We'll have T and we'll have E. And I don't know if I have to type this twice or if once I do one impl, they all become impl. We could check the parser real quick. So this will be parse ability deafen. And we're going to look for that keyword impl. And this is for every type param we look for impl. So that's exactly what it's doing. So we can close out of that and back to here. So that's how we would say this. The consequence of this is that you can only implement resultee once per type because it doesn't carry any non-impl parameters. If I had a non-impl parameter, foo, then for every foo I give, the implementation, so I could implement it once per foo, and then that implementation could provide a T and an E. In this case, though, we don't, so we can only implement resultee once for our type, which is what we actually want. I'm using a name that I definitely won't keep because I don't know what to call this. Let's call it try. Rust calls it try. I think that might be all we need. So what are we trying to build here? It's big enough. Let's just make it even bigger. And think about, let's crack open a file, the root of our repo. We'll call it ret error. Let's go ret error, returning errors. And we'll sketch this out. Fail. And this is going to return a result of int if it succeeds and a string if it fails. And let's def type alias error. And that's just a string. So that way we can say error, and that'll be nice. All right. For now, we'll do the classic return 42. And main has to return an int right now, although I don't type check main yet. So I'm gonna say main also returns int or error for this example. And this is gonna return dot OK of 0. And eventually I do want to support this. Same way you would in Rust. So what I want to do is I want to be able to, so obviously this is returning a result and I'm saying I have an integer. What I want to be able to do is, or basically else return, say. There's problems with using else, but, and then if it failed, the whole function would return an error. Otherwise, it yields, it extracts the success value. So, because I'm not sure about syntax, you typically want something really lightweight for this. I'm going to go with try, actually. And we'll make it a function-like call, because it's easy for me to make built-in function-like things. And maybe I can prefix this to indicate it's a placeholder. So we could do ph try. No, let's just say try. And you probably wouldn't want to make this look like a function because the semantics of this are unlike any other function. It can do things that functions simply can't. Kind of breaks the rules. You know, the rule of a function call would be this code will be evaluated and then this will produce an expression and then whatever it produces, you know, will be the result. And this doesn't do that at all. It kind of, you know, because it can return. So what does this become? This will become let R, and we'll do our syntax for kind of what our compiler generates, these like obfuscated with like, right, these obfuscated variables. So we'll do v. It's going to first call this, it's going to assign it to a variable so that it doesn't call it multiple times. It's a lesson you learn whenever you synthesize code inside a compiler. So we have v, and then, you know, this won't actually be a line, but we'll be like, does v implement try for some pair of types? Does v implement try? Actually, not for some pair of types. Does v implement try? Yes. If so, find out what t and e are. Okay? And the way our compiler works, when we ask if v implements try, we're actually going to get back an implementation ID. Yes, it implements try, and here's the implementation. That implementation will have concrete values for t and e, type, a concrete type, values for the types of t and e. So what t and e are, we'll just grab them from the implementation. So then we'll know what t and e are. Great. So then we'll say, okay, in case we didn't have a type annotation, our whole expression is going to return t in that case. So and then we'll probably synthesize an if. And this is going to be if v is success. And let's go error first. In the spirit of short-circuiting and dealing with errors early, even our synthesized code is going to deal with the error case first. That's going to be a return. It's going to synthesize a return node, return command or instruction. And that's going to be v.getSuccess. Else v.get. Sorry. And not quite, right? Because the nice thing about this operator is it does your error wrapping. So that's going to be, you know, let's just spell it out, result.error. That's what it produces, right? Get success. And return, return produces an expression of type never in this language, which is important because the compiler, when it goes to figure out the type of this whole construct, it's going to see that one of the branches produces never, which means it never produces a value. It returns, but that's something we got to worry about elsewhere. We're going to have to check that this block, what the return type of this whole block is, which we'll get to. But this expression doesn't return an error. It actually diverges. So then what it will do is it will just look at the branch, at the else branch to determine what value we're producing. And since get success returns a t, which is going to be int, this is going to be a-okay. So it's going to produce an int. And then of course, let's definitely do our result here. Okay, and the error we're seeing here is actually because these the double underscore prefix is explicitly prohibited because that's what we use for compiler hidden only things. So this prevents user code from ever actually referring to them without having to introduce like a magic separate scope, which might be a bit cleaner, but this is kind of nice. Okay. And for this to type check, yeah, baby steps. Let's come here first, right? Yeah, I'm actually going to close this buffer and switch to oh no, this is right. We'll do this. We'll have built-in. Well, I kind of want to close everything except for our ret error. You know what? Let's just open it up. Okay, clean state, function not found, try. Let's do some error-driven development then. So I'm going to search for lookalike, because I have handle built-in function called lookalikes. Return and break are actually some of them. And we'll come here and let's do try. And it's going to be, well, let's start here. Okay. So in this case, we have to think already a little bit. I'll just put this here to turn it back green, about what the expected type is. So this is something that we can do so that type inference works well. This is where we pass the expected type, and we're passing none, so no hint, basically, to this expression. So if this were an expression that would be helped by a hint, we're not going to have it. We're expecting int here, and then we expect this to be an option. So what we can say, what we could say if we were always using result is, if we're expecting an option, if we're expecting a value, whatever value we're expecting, go ahead and expect a result where the success value is int, or is that value, and then the error is something we don't know yet. I think that's going to be a little bit tricky, so we're going to pass none. Then we could say to do, you know, perhaps thread expected type through somehow. It's difficult with the ability requirement. So the first thing we need to do is check if this thing implements try. So we can get its type. I'm going to say let sum. Oh no, that was gone and now it's back. And this is going to be find ability impl for type. And the self type, so the type that should implement try, is the expression that the user passes. And the ability is going to be try ability ID, which we don't have yet, but we're going to store in a constant. And then the span is going to be the call span, the call span. And then we're going to check. Yeah, so let's sum, and this is going to be else. No, actually, I have a better one. I actually have expectability implementation for this exact case. And I think we're going to have an option here. Yeah. So let me find my ability IDs. Yeah. Try. And we'll make that 5. This is a messy system. You can probably see what I'm doing here. Well, I'll improve it one day. Here's the try impl. So let's just start here. And, well, it's going to return none, so it's not going to register as a lookalike, and then something else bad is going to happen. Red error. So missing ability try implementation. Yeah, right, because we're doing the check first, and we don't have it. For result I64 string. It implements the following abilities, none. That's really nice. So we got here. If I run my command, maybe this will be the first time. Yes, okay, so it doesn't implement try. That's something we can do for result. So I do support blanket implementations, but I'm not going to test one here because I don't want to derail the video. So we're going to just implement try for result and error. And we're going to provide is success. And I realized we didn't pass self into those, so that's going to be a problem. And that needs to be a bool. And that's going to be self is dot okay, if anything. and then we're going to do get success and get error. T is int, and E is error, which is really string. And I can use T or int here. And I can use E or error here. They're the same thing. We'll do TE, match the ability definition. Self dot as okay. And I think that's dot value. Function not found. Did I really one-shot this? I sure did. Wow. No type named elf is in scope. 1 second. So now we're seeing function not found because I'm actually returning none here. So let's do this instead. Fail. Hands are a little cold. That's why I can't type. It's my excuse. Not done yet. Okay, so I can do this, and then if I rebuild the compiler and reload it, not done yet becomes our error. So we got further. And let's just log. Let's log the thing. So the impl types are. And now we have a try impl. So get ability impl, try impl, full implementation ID, impl arguments. And this is a vec of simple named type. So I'll just name this impl args for niceness. And what we'll say is pretty print name types. And I think that's going to want that. And I think that's going to want a separator. And maybe I needed to do that. Need to borrow. And let's try this one. We'll just run, since we need to see the standard out. The impl types are T is I64 and E is string. So what's great, that means that we're here. So we've run this, we have the type. So we are here. I haven't made the block yet, but we're kind of here. So now we need to start making code. We have everything we need to start making code. Let's do iter find, and then we'll panic if we don't. Name int for name type. This is going to be get ident E. And let's do find.map, not find map. Map int type ID. That's a find. So this will be an unwrap. Just an unwrap. And then we'll have our OK type. We'll say success type. This takes self. This takes self. And that's type T. This So now we really know what they are. Let's remove this. And let's say let result block synthesize. Let's start making some code. Synth block. For now. Well, okay. How many statements is it going to have in it? I can pre-allocate. We'll just make it empty for now. The parent scope is interesting. So the parent scope is the scope that try was called from. Yeah, the scope that try was called from. So calling scope is perfectly fine here. The scope that try, because we're inside a function call, or at least the compiler thinks it's a function call at this point. And it's only once we recognize this name that we say, hey, this just looks like a function call, but really it's something else, like break or return, or in this case, try. So, you know, really this code probably won't stay here, but all of this code is what we'll keep. And we probably pull it out into a function here in a minute. And this can just be the the span of the call, really, of the whole call is who's responsible for this. So now we have a block. And we're going to self.block2string, actually, our result block before, so that we can see it as we build it. And what's the first thing we want to put in this block? Let v equals can fail. So that's going to be synth variable definition simple, with a name. Ooh, we need a name. So let's call this try value. Try value. And this is going to be mangled. Creates a non-mutable, mangled, non-referencing variable. So a normal one. Initializer. That's the result. Is that it? Owner scope. That's the scope of our block. Let try value var. This returns what a struct called synth variable. Has a variable ID, which can get you to everything you'd want to know about a variable. A definition statement, that's what we're going to use. We're going to put that in our block. An expression that always points to the variable, we'll use that too in a parsed expression, which we won't use. Let's make this mutable because our result block is about to get a value. Result block push statement, try value var definition statement. Let's run this, and then we should actually see that our missing identifier try value and pool. So this getIdent expects it to be in here. It's sort of a slight optimization from doing a get or insert. So if we just go to the parser and find the built-in identifiers, we'll add a new one. Try value. And we're not done yet. And I forgot to log our block. But we can check now. There's nothing in it. Maybe we should log it after we put a statement in it, huh? Let try value 663. This is the scope ID. Make sure that it doesn't collide with any other try values. That's all taken care of for us by this synth variable definition. The dunders, the scope ID, lots of other things. It has the correct type and it equals can fail. That's great. So now let's do our if expression. Do we have synth if? Nope. So this is going to be a typed expr if, which wants typed if, I would expect. And we'll use the magic of fill struct fields here. So we need to make one of these. We need to say the condition. So this is going to be, we decided to call is error. So this is going to be is error fun call. We need to make that. Whoops. How dare I? Is error fun call. Consequent is going to be the return error expression. The alternate is going to be get success fun call. So we have to make all three of those. And the type of this node is going to always be the type of get success, which is just the success type. So I knew we'd need this. That's going to be the success type. If we put the wrong type here, you know, it's game over. We're saying here's a typed expression. So no one's going to type check this for us. We are the type checker. We're synthesizing this code. It has to be correct. So it needs to be right. Definitely messed that up before. And then this is going to be the call span. Let me just make sure we didn't miss anything. Box you up. Okay, those are our three. And if all goes well, let's just go ahead and return our result block. Let's start with his error. Yeah. Any type arguments? No, I think I just want to let it infer. Arguments, though. Is error just takes one thing, and that's the receiver, we would say, which will be our result. It will not be. It's going to be our result var. So it's very important. This is the same thing as what the user passed in, but this is the version of it that's in the variable. If we put result here, then it would be, then we would synthesize this code. And that's a problem in case the function can fail does things, like, I don't know, any side effects at all. So we use v here. So qident is a little helper. Self span. Namespace is name. Okay. We're definitely doing is error. Just checking on the ability here. Is success. Whoops. All right, I'm gonna do it in the other order now because adding a negation node is not what I want to do. So is error, no. That's not what we're gonna do. We're gonna do is success. And we're gonna swap these around. So what this is actually going to invoke, I should fix it. It's going to be more like this code, which doesn't use method call syntax. Not that it matters. Cannot find what? Expected type. I mean, there's no type inference going on here. That can fail. I think mainly it can fail if this namespace resolution fails. So now we need return error. No. Get success. All right, we'll do get success now. Just realizing I don't love these names, but I guess that's totally beside the point. Yeah, I'd say it is beside the point. Oh, that's all we passed too. Okay, now it's only the return error. This one's more complicated because we're doing an enum constructor inside a return, inside a function call. So let's just start with a get error, because that's going to be basically this. Whoops. Am I crazy? Okay, get error. And enum constructor. Error conster. Enum constructor. If I wanted to do something easier, I could make a helper called OK. Oh, actually, no, I don't know. Oh, shoot. This doesn't work. Because this assumes result, but I'm just saying anything that implements. Try. So I actually need a way to construct the error variant in the ability. So this would be make error. Oh, and it returns self. Woohoo. E to self. Oh my goodness. That's actually really cool. Oh, and then this turned red. Which is amazing. Make error. Please compile. Oh. Missing make error, huh? Oh no. Oh, we're not compiling right now. That's true. We're at 40 minutes. I think this is a good stopping point. Keep you on the edge of your seats, or maybe I'll edit in the next day. 2 seconds from now. I don't know. Yeah, but I'm really happy with this progress. I think you can see how this is shaping up. We might hit a couple more gotchas along the way, but that's kind of what it's all about. Learning, kind of discovering, building. So yeah, thanks for watching. Hope this one turns out well. Ends as well as it started, right? All right, next time.